Hello students, our today's class is about the continuity of a function. Okay, so if there be a function y equal to fx and that function is defined in the interval x equals to a to b, and if there be a graph of the function is without gap or break at any point x equals to c, in that interval is that the graph drawn on two sides of the point x equals to c passes through the point c comma fc, then the function y equal to fx is said to be continuous. So if there be a graph y equals to fx and at the point x equals to c, if we check and the graph is continuous in the two sides of this point x equals to c, then we say that particular graph is continuous. And how we can check whether a function is continuous or not? If a function be like this, if we draw a graph for a function and it will look like this, that means there is a gap here. Okay, there is a gap here. And if there be no gap for a graph, then we say that particular function is continuous. Now how we can check it? We'll check it in this way. Limit x tending to a plus fx equals to limit x tending to a minus fx equals to fa. If these three are equal, then we say the function y equals to fx is continuous at the point x equals to a. These two together, that means this one, limit extending to a plus fx and limit extending to a minus fx. This we can say this is actually the right hand limit and this is the left hand limit. And if they equal, that means the limit exists. So from these two we can say limit x tending to a fx. So limit value, if that one is equals to fa, that means the functional value or the value of the function at the point x equals to a. If these two are equal, we can say this function y equal to fx is continuous at the point x equals to a. So this is the main theory behind it. Now say we have a function y equals to mod x by x. Okay, y equals to mod x by x when x equals to 0, and it is equals to 1 when x equals to 0. So we are going to check whether this particular function y equals to this is continuous at the point x equals to 0 or not. See, in case of mod x, what do we know? Mod x is equals to actually mod x equals to x when x greater than 0. It is equals to minus x when x less than 0. So in this way we can redefine the function. So if we redefine the function, it will look like this: y equals to x by x, that is equals to 1 when x greater than 0, y equals to minus x by x, that is equals to minus 1 when x less than 0, and it is equals to 1 when x equals to 0. So this is the definition of the function y equals to fx. Okay, now from this definition, if we want to check whether it is continuous or not, limit extending to 0 plus fx. If we want to find out this one, limit extending to 0 plus fx. 0 plus means the value of x is greater than 0. this one. And how the function defined? The functional value is equals to 1. So limit x tending to 0 plus 1, so the value equals to 1. Next one is limit x tending to 0 minus fx. And how the function is defined? X tending to, for x tending to 0 minus, that means the value of x is less than 0. See, the function is defined in this way. The functional value is minus 1. So minus 1. So it will be minus 1. And what is the value of f0? That means when x equals to 0, the functional value is equals to 1. 1. And these three are not equal. For continuity, these three should be equal. But as because these three are not equal, hence we can say this function y equals to this mod x by x is not continuous at the point x equals to 0. Okay. Next one. Question number 2. In question number 2 we have fx equals to kx plus 5 fx equals to kx plus 5 when x less than equals to 2, and this one is equals to fx equals to x minus 1 when x greater than 2. x1 equals to x minus 1 when x greater than 2. Now we want to check the continuity for this function. See, first of all, from this function definition it is evident. See here, x less than equals to 2. So we are going to check the continuity of this function at the point x equals to 2. Now x less than equal to 2. For x less than 2, the function is defined in this way. Even when the value of x equal to 2, the function also defined in this way. Okay. Now let us check limit x tending to 2 plus fx. When the value of this function, this x, is greater than 2. 2 plus means it is more than 2 or greater than 2. The function is defined in this way. So we will write limit x tending to 2 plus, and the function is x minus 1. Now if we put this 2 at the position of x, we will get 2 minus 1, the value is equals to 1. Okay. Now again, limit x tending to 2 minus fx. How the function is defined? When the value of x is less than 2. Here, the function is defined in this way. So limit x tending to 2 minus, and the function become kx plus 5. Now if I put 2 in this function, I will get 2k plus 5. Now again, what is the value of f2? When the value of x equals to 2, the function is defined in this way. Though that means f2 will be equals to 2k plus 5. Now from here, this function is said to be continuous for what value of x? So by equating these two, for continuity these three should be equal. So for equating these two, we can get the value of k. So 2k plus 5, 2k plus 5, for continuity 2k plus 5, that is equals to 1. That should be equals to 1. So from there 2k equals to 1 minus 5 minus 4. So k equals to minus 2. Hence, for k equals to minus 2, this function is continuous. Next one. Question number 3. In question number 3 we have fx equals to 2x plus 1 when x less than 2. when x less than 2. Fx equals to k when x equals to 2. When x equals to 2. Fx equals to 3x minus 1 when x greater than 2. Okay. Now we want to, here it is given, this function is continuous at the point x equals to 2, and from there we have to find out the value of k. Okay. So again, it is similar like the previous one. So in the same way we can do it. So limit x tending to 2 minus fx. When the value of x is less than 2, how the function is defined? In this way. So limit x tending to 2 minus 2x plus 1. So if I put 2 in this function, 2 into 2, 4 plus 1. So it is equals to 5. Okay. When the value of x is more than 2, that means 2 plus x tending to 2 plus fx. So there x tending to 2 plus, the function is defined in this way, 3x minus 1. So if I put 2, it becomes 3 into 2, 6 minus 1, 5. And if 2 is given as k. So for continuity, these three values should be same or equal. So from there you can say the value of k equals to 5, as the function is continuous at the point x equals to 2. Okay. Next one. Question number 4. In question number 4, we have a function fx equals to 3 plus 2x when x is greater than minus 3 by 2 and less than equals to 0. Less than 0. Fx equals to 3 minus 2x when x greater than equal to 0 and less than 3 by 2. And fx equals to minus 3 minus 2x when x greater than equals to 3 by 2. Now the thing is that here for this function we have to show this function is continuous at x equals to 0 but discontinuous at x equals to 3 by 2. Okay. First of all, we want to check the continuity for this function at the point x equals to 0. So how to redefine the function, or from the definition what should we take? For checking for this function whether it is continuous at x equals to 0, first we check how it is defined when x less than 0. See, when x less than 0, it is defined in this way. When x less than 0, the function is this one. Again, we have to check how it is defined when the value of x is greater than 0. See, when the value of x is greater than 0, function is defined in this way. And again, we need what is the value of function when x equals to 0. Again, for this equal to sign, when x equal to 0, the function again defined in this way. So for checking continuity at for some point, we have to check how the function is defined. How the function is defined means what is the value of the definition of the function when the value of x is less than that particular point. What is the value of that function when the value of x is greater than that particular point, and what is the value of the function when the value of x is exactly that point. Okay, this should be the rule. So we are going to check whether this function is continuous at x equals to 0 or not. Okay, so limit x tending to 0 minus fx. So that is equals to limit x tending to 0 minus, how it is defined? 3 plus 2x. 3 plus 2x. So if I put x equals to 0, it becomes 3. Again, limit x tending to 0 plus fx. How it is defined? For x tending to 0 plus this one. Okay, so how it is defined? 3 minus 2x. If I put x equals to 0, I'll get 3. And what is the value of f0? f0. That means here in this function we have to put x equals to 0. So it becomes 3 if we put x equals to 0 in this function. So these three values are same. From here we can say the function is continuous at the point x equals to 0. Now we are going to check the continuity of the function at the point x equals to 3 by 2. Now again, when we want to check whether the function is continuous at the point x equals to 3 by 2 or not, there we have to check how it is defined. When the value of x is less than 3 by 2, how it is defined? See here, the value of x is less than 3 by 2, so it is defined in this way. What is the value of the function when x is more than 3 by 2? How it is defined? So here, this is how it is defined when the value of x is more than 3 by 2. And what is the value of the function when x equals to 3 by 2? Here for this equal sign, again in this way. Okay. So first of all we have to find or check whether we have these three definitions or three values or not. Then after that one we will check whether the function is continuous at that particular point or not. Okay, so we are going to check whether this function is continuous or discontinuous at the point x equals to 3 by 2 or not. Okay. Three by 2 minus. So when the value of x is less than 3 by 2, it is defined in this way. 3 minus 2x. Now if I put x equal to 3 by 2, 2 into 3 by 2, this 2 get cancelled, 3 minus 3, 0. Okay. Now again, limit x tending to 3 by 2 plus. Okay. So when the value of x is more than 3 by 2, how it is defined? It is defined in this way. Minus 3 minus 2x. Now if I put x equal to 3 by 2, what do we get? Minus 3 minus 2 into 3 by 2, 2 to get cancelled, minus 6. And when the value of x equals to 3 by 2, so that means f 3 by 2, what is the value of the function and how it is defined? It is defined in this way because for this equal sign. So it is defined in this way. So minus 3 minus 2 into 3 by 2, 2 to get cancelled, so it is equal to minus 6. So 0, minus 6, minus 6. So they are not equal. So as these three are not equal, we can say the function is not continuous or discontinuous at the point x equals to 3 by 2. Okay. Next question. Okay, here we have a function fx, question number 5, fx equals to x square minus 1 by x cube minus 1. Okay, now here it is given this function fx equal to x square minus 1 by x cube minus 1, it is undefined at x equals to 1. What should be the value of f1 such that fx may be continuous at x equals to 1? So for this function, what should be the value of f1 for that this function is continuous at the point x equals to 1? First of all, by the definition, the limit value of this function should be equals to f1 to make this function continuous at the point x equals to 1. Okay, so for that reason, first of all we have to find out the limit value for this function fx. So what is that? Limit x tending to 1, x square minus 1 by x cube minus 1. X square minus 1, it can be written in this way, x plus 1, x minus 1, and this x cube minus 1, if we factorize it, we can write it in this way, x minus 1, x square plus x plus 1. This x minus 1 can get cancelled. Okay, this get cancelled. So from there, if I put x equals to 1, what do I get? 2 by 3. Okay, So this is the limit value of the function. And for the sake of continuity for this function, this limit value should be equals to the functional value of the function at the point x equals to 1. So this should be equals to f1 to make the function continuous at the point x equals to 1. Hence, our answer is f1 equals to 2 by 3. Next one. Question number 6. In question number 6, we have a function fx equals to x plus 1. This is how it is defined, fx equal to x plus 1, and another one is 3 minus ax square. 3 minus ax square. First one is defined when x is less than equals to 1, and second one when x is greater than 1. Now here it is said the function is continuous at the point x equals to 1, and from there we have to find out the value of this a. Okay, how we can find out? So first of all, this function, it is continuous. That means again from the definition we can say when x is less than 1, when x is greater than 1, and the functional value, those limit values and the functional value, they should be same. So we are going to find out this one, limit x tending to 1 minus fx. When the value of x is less than 1, how it is defined? This way. So limit x tending to 1 minus x plus 1. So if I put x equals to 1, we get 2. Again, limit x tending to 1 plus fx. How it is defined? When the value of x is greater than 1, 3 minus ax square. So this much equals to, if I put x equals to 1, 3 minus a. And what is the value of f1 when x equals to 1? If I put x equals to 1, I will get 2. Now these three should be same, these two already same. So this one should be equals to this one to make this function continuous at the point x equals to 1. So if I make these two same or equal, so 3 minus a equals to 2, or the value of a equals to 3 minus 2, 1. So the value of a equals to 1 as the function is continuous at the point x equals to 1. Next question. Question number 7. Okay. In question number 7, we have fx is a function that is equals to 1 minus cos alpha x by x sin x. Fx equals to 1 minus cos alpha x by x sin x. Okay. And this one is when x not equals to 0. And the functional value when x equals to 0, this is equals to half. This is equals to half when x equals to 0. Now we are going to check whether the function is continuous. It is said that the function is continuous, okay, at x equals to 0, and from there we have to find out the value of this alpha. Okay. Now from the definition it is evident when x not equal to 0, that means the value of x can be less than 0 or it can be greater than 0. So in both cases the function is defined in this way. Okay. So by just finding the limit, okay, limit for this function at x equals to 0, we are covering actually the both cases. Okay. So first of all we are trying to find out limit x tending to 0 fx. So when we are writing this one, we are actually covering both the cases, that when x greater than 0 and when x less than 0. So this one, the function is defined in this way. Limit x tending to 0, 1 minus cos alpha x by x sin x. Okay. Now, 1 minus cos alpha x. 1 minus cos alpha x means 2 sine square alpha x by 2, okay, by submultiple angle chapter. 1 minus cos theta equal to 2 sine square theta by 2, and here we have x sin x. Now from there is equals to limit x tending to 0 to we have sine square alpha x by 2. For this one, if I divide it, alpha square x square by 2 into alpha square x square by 2 means 4. It should be 4 by x sin x. X sin x. Again, I am dividing it by x square into x square. Okay, this is what I am doing. Now from here, what we can say? Sin alpha x by 2 by alpha x by 2 whole square. That we can write. So that's why I have written in this way. So 2 into limit x tending to 0 sin alpha x by 2 sin alpha x by 2 by alpha x by 2 whole square. That we can write. And from here, this x square get cancelled with this x square. So here we have this x cancelled with 1x will remain. So sin x by x we have here in the denominator part, sin x by x. And here what remains? Alpha square by 4 into alpha square by 4. So this part is equals to 1, this part is equals to 1. This 2 and 4, if we cancel, we will get a 2 here. So alpha squared by 2. So value of this limit is equals to alpha squared by 2. As because this function is continuous at x equals to 0, what we can say? This alpha squared by 2 is equals to 1 by 2. So if we write this alpha squared by 2, that is equals to 1 by 2. 2 get cancelled, so alpha square equals to 1. So alpha equals to plus minus 1. Hence the answer. Okay. Okay, next question. See, in this next question, what we have this function fx equals to 3ax plus b when x greater than 1. It is equals to 11 when x equals to 1. It is equals to 5ax minus 2b when x less than 1. Here it is given that function is continuous at x equals to 1. And from there we have to find out the value of or values of a and b. Okay. So how we can do it? As because this function is continuous, so first of all we'll apply this one, limit x tending to 1 plus fx, and that is equals to limit x tending to 1 plus, how it is defined? When the value of x is greater than 1, 3ax plus b. So 3ax plus b. Now if we put x equals to 1 on this equation, what we get? 3a plus b. Next one is limit x tending to 1 minus fx. Limit x tending to 1 minus. How it is defined? When the value of x is less than 1, it is defined in this way. 5ax minus 2b. Now if I put x equals to 1, what do we get? 5a minus 2b. Now the functional value. When x equals to 1, it is equals to 11. So if 1 equals to 11. So from this, as we know, this function is continuous at x equals to 1, it is said. Now from here we have to find out the value of a and b. So these three are equal. 3a plus b equals to 5a minus 2b equals to 11. Now from this thing, what we can do, we can form two equations. One is 3a plus b, that is equals to 11. Another one is 5a minus 2b, that is equals to 11. Now from these two equations we have to find out the value of a and b. Let me multiply this equation by 2. If I multiply this equation by 2, it will be 6a plus 2b equals to 22. So by add, this 2b get cancelled. So 11a equal to 33 cancelled. So a equals to 3. Now if I put in any of the equation a equal to 3, what do I get? 9 plus b equals to 11. So b equals to 2. Okay, so the value of a equals to 3 and the value of b equals to 2. Hence the answer. Next one. In question number 9, we have fx equals to x to the power 4 plus 2x cube by sine square x when x not equal to 0. This one equals to 0 when x equals to 0. Okay. Now from this definition, we have to check whether the function fx is continuous at the point x equals to 0 or not. Okay. So that's because here it is given x not equal to 0. That means x can be less than 0 or x can be greater than 0. So from there we can say we just have to find out the limit point or limit value for this function for both the cases, when x less than 0 and when x greater than 0. So limit x tending to 0, x to the power 4 plus 2x cube sine square x. As because in the denominator portion we have sine square x, we have to divide the numerator and the denominator by x square. So if I divide the numerator and the denominator by x square, what do I get? X to the power 4 plus 2x cube by x square. Here it is sine square x by x square. Sine square x by x square, that means it is sine x by x whole square. Limit x tending to 0, sine x by x whole square. Limit x tending to 0, sine x by x, that is equals to 1. So from there you can say, here it becomes limit x tending to 0, x square plus 2x, and here it is sine x by x whole square. This part becomes 1, and if I put x equals to 0, the numerator becomes 0, so 0. Total value becomes 0. And here the functional value, that means when x equals to 0, the value of the function becomes 0, that means f0 is given as 0. So as because the limit value of this function and the functional value, these two are equal, from there we can say this function is continuous at the point x equals to 0. Next question. In question number 10 we have a function fx that is equals to px minus q when x less than equals to 1. That is equals to 3x when x greater than 1, less than equals to less than 2. That is equals to q x square minus p when it is greater than equals to 2. Here it is said the function is continuous at the point x equals to 1 and x equals to 2, and we have to find out the value of p and q. Okay. Now, as because the function is continuous at x equals to 1, from the definition we have to find out how it is defined for x equals to 1. When value of x is less than 1, it is defined in this way. When the value of x is greater than 1, it is defined in this way. And when the value of x equals to 1, it is again defined in this way. Okay, so first we have to find out how it is defined. Now after this one, as because it is continuous at x equals to 1, so limit x tending to 1 minus fx. And how it is defined? Limit x tending to 1 minus. It is defined in this way. That means when the value of x is less than 1, it is defined in this way. So it will be px minus q. Now if I put x equals to 1, I get p minus q. Again, when the value of x is greater than 1, that means limit x tending to 1 plus fx. How it is defined? Here, in this way. So limit x tending to 1 plus, and it is defined in this way, 3x. So if I put x equals to 1, it becomes 3. Now, f1, what is the value of f1? This one. If I put x equals to 1 in this equation, I get f1. So it will equal to p minus q. Now the thing is that as because the function is continuous at the point x equals to 1, that means these three values will be same. Already we can see these two are same, p minus q, p minus q. So from here we can say that p minus q equals to 3. This much we get from here. Now again it is said the function is continuous at the point x equals to 2. Now how it is defined? for x equals to 2, when x less than 2 it is defined in this way. When x greater than 2 again it is defined in this way. And when x equal to 2, see for this equation it is defined in this way. Okay. So for the continuity at the point x equals to 2, if we want to check it, so limit x tending to 2 minus fx. For this one, for 2 minus the value of x is less than 2, it is defined in this way, 3x. So it will be limit x tending to 2 minus 3x. If I put x equal to 2, it becomes 6. Limit x tending to 2 plus fx. When the value of x is more than 2 or greater than 2. So it is defined in this way, qx square minus p. So limit x tending to 2 plus, it becomes qx square minus p. If I put x equals to 2, that means 4q minus p. And what is the value of f2? For equal sign, again we will take this one, so f2, that is equals to, if I put x equals to 2, it will become 4q minus p. So again, for the continuity at the point x equals to 2, these three should be same. This one, and this one. These three should be same for the continuity. So from there, these two already equal. So from here we can say that 4q minus p equals to 6. So what do we get? 4q minus p, that is equals to 6. Now if we add this to p, get cancelled. Okay, so 3q equals to 9 or q equals to 3. Now if I put q equals to 3 in any of the equations, say in this equation, q equals to 3. So p minus 3 equal to 3, so p equals to 6. Okay, in sums. So the value of p is 6 and q equal to 3. Next one. Okay. So the next question is question number 11. If x equals to x cube plus x square minus 16x plus 20 by x minus 2 whole cube, when x not equal to 2. It is equals to half when x equals to 2. From here we have to check whether this function fx is continuous at the point x equals to 2 or not. Okay. So as because from the definition of the function we can see that when x not equal to 2, it is defined in this way. X not equal to 2 means the value of x can be less than 2 or it can be greater than 2. In both the cases, we just have to find out limit x tending to 2. Okay, by that one only we will cover both the cases, when x less than 2 and when x greater than 2. Okay, so for both the cases the function is defined in this way. So we are going to find it, the limit value of this function at x equals to 2. So limit x tending to 2, x cube plus x square minus 16x plus 20 by x minus 2 whole cube. So our first work is to factorize the numerator. Okay. So limit x tending to 2, x cube is here, so x square, x cube minus 2x square, that means plus 3x square minus 6x is minus 10x minus 10x plus 20. So here we have x minus 2, x square plus 3x minus 10. That can be written as 5x minus 2x minus 10. And here we have x minus 2 whole cube. 1 is cancelled, so it becomes x minus 2 whole square. Okay. If I cancel it, it was previously 3 cancelled, it becomes square. Now, after this one, after this factorization, what do we get? Limit x tending to 2, x plus 5. And here we have x minus 2, another one, and this one is x minus 2 whole square. So this x minus 2 get cancelled with this one. Now limit extending to 2, and what do we have? X plus 5 by x minus 2. Okay. So at the point x equals to 2, this function become undefined. We cannot put x equals to 2 in this function as because it becomes undefined. Okay. So this portion, when x not equal to 2, this particular function from the definition, it is undefined, and for the at the point x equals to 2, the value of the function is half. Hence the function fx is not continuous at the point x equals to 2. Okay. So again I am repeating, from here at the point x equals to 2, the function become undefined. As the function is undefined, and from here when x equals to 2, it is equals to half, so this is not continuous. Okay. Next question. Next question is this one. Question number 12. If x equals to log of 1 plus sine 2x by x not equal to 0 equals to 1 plus a, x equals to 0. Here it is given the function is continuous at x equals to 0, and from there we have to find out the value of a. See again, from it has a similar kind of definition. X not equal to 0, it is defined in this way. So when x less than 0 or for x greater than 0, the definition is same, that is this one. So we just have to apply limit extending to 0 for this function. Limit extending to 0 fx. For both the cases it is defined in the same way. So limit extending to 0, log 1 plus sine 2x by x. Okay. Now what do we know? Log 1 plus x by x, limit extending to 0, the value become 1. So we are going to apply that formula only. Okay. So limit extending to 0, log 1 plus sine 2x. So for that one, for taking this one into formula, we have to divide it by sine 2x. So sine 2x I am given here. So that's why here I have given 1 sine 2x, and x was already present. But again, to take this one into formula, we need 2x. So I am giving a 2. For that one, I am multiplying it by 2. Okay. So this is the thing. So this part, this particular part, it is equals to 1. This particular part, again, it is equals to 1, and that is equals to 2. So the value become 2. Okay. So as because the function is continuous at the point x equals to 0, so this part, the functional value 1 plus a, that should be equals to 2. So from there we get the value of a, that is equals to 1, and hence the answer. Okay. So today up to this one, next day we'll start with differentiability of a function. Okay. Thank you.